everyone, and welcome back to my online teaching platform. Still on application of differentiation. We have our eighth question over here. We are to find the values of x for which the gradient function of the given curve is 0. Alright. Now, we are to find the value of x for which the gradient function of the given curve is 0. Alright. Now, what is a gradient function of a given curve? That's what you need to know. You need to know what a gradient function is. We have done that already. So we know the gradient function to be the same as the derivative of the given function. Alright. So given the function to be y equal to 1 out of 4, that's 1/4 x cubed, exponent 4 plus 2/3 x cubed minus half x squared minus 2x plus 1. We are to find the value of x for which the gradient function of this given function is equal to 0. So let us find our gradient function. dy dx is our gradient function, meaning we are differentiating y with respect to x. We are going to get it. The first one will give us x exponent 3, and the second will give us 2 exponent, 2 multiply x exponent 2. Then the next one gives us minus x minus 2. Alright, so you need to differentiate the function to get its gradient function. But there's a condition that the gradient function is 0. We have to find the value of x in the given function for which its gradient function is 0. So this implies that our dy dx is equal to 0. Alright, we are going to get x cubed plus 2x squared minus x minus 2 to be equal to 0. So this is the equation that we are going to solve to get the value of x for which the gradient function is equal to 0. Alright. So this is the gradient function. This is our gradient function. Yes. Okay. Our gradient function is that dy dx equal to x cubed plus 2x squared minus x minus 2. And we have to find the value of s for which it is equal to 0. So we have our new equation to be x cubed plus 2x squared minus x minus 2 equal to 0. Alright. So we are now going to find the value of x. So we start by stating the vertex of the constant term, which is -2. Alright. So we are going to identify the positive and negative factors of -2. So the first factor will be plus or minus 1. Then the next one will be plus or minus 2. Alright. So we test for the factors. So let us start with -1. So when you plug in -1, you start to -1 and see whether the left hand side will be equal to the right hand side. So -1 squared, then minus -1 minus 2. Let's see if it will be equal to 0. We are going to get equal to 0. Let's see. So here will be -1, here will be plus 2, and here will be plus 1, and here will be minus 2. Right. So we are getting the result to be equal to 0. Alright. So it means one of the x value is -1. Alright. So we could say when you substitute negative, when you substitute -1, you get a value to be equal to 0. So we could say that the left hand side is equal to the right hand side. So one of the x values is -1. You can equally use your calculator to get the answers, but when you are done, you need to use one of them to get a factor, a linear factor, so that you can use it for the division. because you have to show working when it comes to examination. You have to show working. So this is one of the values of x. So we are going to transpose it to get it. We are going to transpose the -1 to where the x is to get it as x plus 1 equal to 0. So this becomes a factor. X plus 1 becomes one of the linear factors of the cubic equation. All right. So we are now going to divide. Every cubic equation has a quadratic factor and a linear factor. So that when you multiply the two, you get back to the cubic equation or the cubic expression. All right. Now we have the expression to be the cubic equation to be x cubed plus 2x squared minus x minus 2 equal to 0. All right. So you pick just the expression part. All right. We are going to pick just the cubic expression. You are not going to involve the equal to sign. All right. So we are going to now divide our x cubed plus 2x squared minus x minus 2 by the linear factor, which is the x plus 1, right? We are going to the x plus 1 here, this particular one. So we are going to use a long division to do that. So this is our divisor, and this is our dividend, right? So when you divide, you need to get a quotient. You need to get a quotient plus a remainder, and the remainder will be divided by the divisor again. Okay. So this is what when you divide, you have to get your answer in this form. All right. So let us start with the division. So let me draw my. Okay, so I have x cubed, then plus 2x squared, then I have here to be minus x, then minus 2. And I'm dividing it by x plus 1. All right. So we have to divide the leading term of the dividend. That is the term with the x with the highest power. So that is x cubed. So this is the term with x with the highest power. And we have the leading term of the divisor to be also the term with the x having the highest power. So this is the term, the first term over here. So we are going to divide x cubed by x, and that will give us x squared. All right. Then you now use the x squared here to multiply each of the terms in the divisor. Okay, so x squared will multiply x squared here will multiply x. We are going to get x cubed. All right. Then the same x squared will multiply the 1, the second term in the divisor, and that will give us x squared. All right. Then you subtract. So x, you're going to subtract. So x cubed my x, this x cubed minus this x cubed give us 0. Then you come to the other side. We have 2x squared minus x squared, and we are going to get the result to be x squared. All right. Then you have to bring down these terms. So we have minus x, then minus 2. All right. Then we continue to divide. We are going to apply the same rule. You divide. Now we are going to divide the x squared. That's the leading term of the remainder by the leading term in the divisor. So when x divide x squared, we are going to get a result of x. Then use the x to also multiply all the terms in the divisor. So we are going to get x times x, x squared. X times 1 gives us positive x. All right. Then you find the remainder. You are going to get x squared minus x squared will give us 0. So we have negative x minus x. So we are going to get negative 2x. All right. then you drop this term, so we have minus 2 here. Now you can see that the power of the x in the leading term of the remainder is still the same as the power of the x in the leading term in the divisor, so it's continuing to divide. So we are now going to divide the negative 2x here by this x, and that will give us negative 2, right? So we'll write it here, negative 2. Then use the negative 2 to multiply all the terms in the divisor. So negative 2 times x will give us negative 2x. The negative 2 times 1 will give us negative 2. Can you subtract nicely? So we have negative 2 minus negative 2 give us 0. Then negative 2 minus negative 2 also give us 0. All right. So we have a remainder of 0. Okay. So this implies that our x exponent 3 minus, sorry, plus 2x squared minus x plus, minus x minus 2 divided by x plus 1 give us a quotient of, all right, x cubed, it's rather x squared minus, or let me check if it's minus, plus, x squared plus x minus 2. All right. So this what we had. There's no remainder, so there's no need for you to bring the remainder plus remainder over the divisor again, because the remainder is 0, right? So it's when you cross multiply, see this over 1. When you cross multiply, you can say that x cubed plus 2x squared minus x minus 2 will be equal to, because this will multiply by 1, and this also multiply this. So you are going to get x plus 1 multiplying x squared plus x minus 2. All right. So where we have the equation x cubed plus 2x squared minus x minus 2 to be equal to 0, we are going to replace this with the expression here. All right. So it's going to be x plus 1 multiplying x squared plus x minus 2 all equal to 0. All right. So here you pick each of the factors. We have the linear factor to be x plus 1 equal to 0. Then you get x to be equal to negative 1. Then you pick when you are done, you pick the quadratic factor, which is x squared plus 1 minus, x squared plus x minus 2 equal to 0. Right. So we need to now factorize this. You find your AC, which is a. So the coefficient of x squared is our a, which is 1. Then the constant term is our c, which is negative 2. We are going to get the result of negative 2. You find two factors of negative 2 that when you multiply, you get the negative 2 as a result. But when you add, you get positive 1, which is the coefficient of the x. All right. So that's what we are going to do now. So the factors are negative 1 and negative 1. Negative 1 plus negative 1 will give us negative 2. Okay. All right. So when you multiply, we are not going to get a negative 2. So let us take a different one and see. All right. So let's take positive 2 and see. All right. Good. So negative 1 plus positive 2 give us positive 1, which is the coefficient of the x, this particular one. Negative 1 times 2 give us negative 2, which is the constant term over here. That is the AC. All right. This is our AC, which is negative 2. So we have our x squared. Then we have it to be negative x plus 2x. All right. You just multiply them by x, then you bring them together. So that negative x plus 2x is the same as x. All right. Then you repeat your constant term in a given expression, which is negative 2. equal to 0, right? So now we factorize by grouping. So we put two terms in one bracket. So x squared minus s in one bracket, then plus 2x minus 2 in another bracket equal to 0. So we have to identify the highest common factor of this bracket, of the terms in this bracket. The highest common factor is x. So bring the x out. X divides each of the terms. X divides x squared will give us x. X divides negative x will give us negative 1. Then you have to apply the same rule here. We identify the highest common factor of the terms in this bracket. The highest common factor is positive 2. And you use the positive 2 to divide each of the terms. So we are going to get x minus 1 equal to 0. So you bring the factors together. So you are going to get x plus 2 in one bracket. Multiply one of the equal brackets to x minus 1. Then everything equal to 0. We have x plus 2 to be equal to 0, or x minus 1 to be equal to 0. So here we are going to get x to be negative 2 and here x equal to positive 1. But we have already solved for one of the x values, which we had it to be negative 1. So we conclude that the values of x for which dy dx is equal to 0 are negative 2, negative 1, and positive 1. All right. So this is how we answer this type of questions. Find the values of s for which the gradient function of the curve is equal to 0. So we know gradient function to be dy dx. That's the derivative of the given function. And they have a condition that it is equal to 0. So you just equate it to 0. Then you solve for the x value. That is, you are going to solve the equation to get the x value. Or you are going to find the root or the zeros to get the x values. So when you are done, you just conclude that this or the values of x for which the dy dx is equal to 0 are, then write the values of x or the zeros of x that you have obtained from solving the equation. Bye bye. Please do not forget to subscribe to my YouTube channel, which is Math with Ebefa. Bye.